All right, the next unit that we're working on has to do with some more integration techniques. And so we're going to use the first day to kind of review and make sure that we are real good with integration, use substitution, that we can do some of the more difficult use substitution problems, and then we're going to kind of move on from there and get into it. So this video is just going to be a review of use substitution because I've been noticing that maybe it would be good for us to kind of practice that again. So this is a U substitution review. Now, if you find yourself not wanting to take notes on this video, please kind of skip through and look at all 5. There are 5 examples. Please look at all 5 of them before you decide you're not going to be taking notes on any part of this, because maybe you're really good at the first couple, but the last couple trip you up. All right, so I just want to make sure that we are good with U substitution still. So all of these examples are asking us to integrate. The first one I'm going to integrate is 5x minus 3 to the 4th power. I can tell that this is a U substitution problem because when I look at this, it looks like I'm going to take like a chain rule or something. And there's no such thing as a chain rule, and integration means we're using U substitution. So here I'm going to say that my u must be the inside of the parentheses, and that means that my derivative of that would be just 5 dx. Since I don't see a 5 sitting out in front of the problem anywhere, that means that I need to divide by 5, because I do see a dx in the problem, it's right there. And so when I do my integration, I'm going to have a 1/5 in front of the integration sign. And then I've got u to the 4th du. So now I can go ahead and find the antiderivative of this. So add 1, divide by 5. So that means I've got 1/5 times, so this is the 1/5 from the front, times 1/5 u to the 5th plus c. And that gives me 1/25. My u was 5x minus 3 to the 5th plus c. Now, I typically write these with a fraction in the front. You can write the whole thing as a fraction. You can say 5x minus 3 to the 5th power all over 25, and that would be totally fine as well. All right, for the next one, we're going to say we've got 2t plus 1 divided by t squared plus t minus 4. And this kind of looks like, oh, maybe we're doing a quotient rule here. But again, there's no quotient rule with integration. And so for me to do this, I've got 2 options, really. I could split this fraction apart because the top has a plus sign in it. So I could do 2t over that denominator and then plus 1 over that denominator. And that does not make this problem any easier. Or I can do U substitution. So when you look at this, you have to figure out which one is going to be the u and which one is the derivative of u. And when I look, I can see that t squared plus t has a derivative of 2t plus 1. So I can see that the bottom is what should be the u, and the top is the derivative of that. So that means that I'm going to integrate 1 over u du. So the integral of 1 over u is ln of u plus c. And so that gives me ln of t squared plus t minus 4 plus c. All right, for this one, we're going to integrate t to the 3rd times the square root of t to the 4th plus 1 dt. I've started to notice that for myself, I recognize U substitution when I can see the same variable written twice, and in one spot, the exponent is 1 lower, because that's what happens when you take the derivative, right? So I've started to train myself to kind of look for that. So in here, again, this kind of looks like a product rule, which you cannot do with integration. It means we're doing U substitution. So the u is going to be inside of the radical, t to the 4th plus 1. The du is the derivative of that, so that's 4t to the 3rd dt. I can see that t to the 3rd, but I can't see the 4. And I need to divide by 4. So I'm going to put a 1/4 in front of this integral, and then I'm taking the square root of u. And I'm going to go ahead and rewrite that so that that radical has an exponent instead. So I'll add 1 and divide by, that's 3/2, so divide by 3/2. And that gives me 1/4 times 2/3 u to the 3/2 plus c. And if I do 1/4 times 2/3, that's the same as 2/12. So we've got 1/6. My u was t to the 4th plus 1 to the 3/2 plus c. All right, let's look at this one. So e to the x over 1 plus e to the x dx. So I know that the derivative of e to the x is e to the x. So it appears that this could go both ways. But I have to think about one of these is on the bottom of the fraction and one of these is on the top. So if I use the top as my u, the derivative of e to the x is e to the x. It's not 1 over e to the x. So that means that I have to use the u as the bottom part. 1 plus e to the x. So just be careful you're watching out for that. If you're using something where the u is on top of the fraction, that means that the derivative would have to be 1 over something that would make it the bottom of the fraction. So be careful of that because that's an easy mistake to make. So the u is 1 plus e to the x. The derivative is e to the x dx. And so that means that we are finding the integral of 1 over u du. So again, we have ln u plus c, which in this case would give us ln of 1 plus e to the x plus c. Okay. We're going to do one last one. We got to do a trig u substitution because trig is your favorite. I know you guys love it. So we're going to do the integral of t times sine t squared dt. So it looks kind of like a product rule, which I know is not possible, so we got u substitution. I can also see a variable here with a t squared, a variable there with an exponent that's 1 less. That's my other classic sign that I'm doing a u substitution problem. So my u is going to be my t squared. The u can't be sine because I don't have a cos anywhere in the problem. So the u is t squared. The derivative of that is going to be 2t dt. I don't see a 2 in the problem, so I'm going to go ahead and divide by 2. I've got that 1/2 in the front times sine of u du. So the antiderivative of sine is negative cos plus c. And so if I rewrite that, that gives me negative 1/2 cos of t squared plus c.